G'day, g'day, g'day. Loser Bum back in the house. And today we have something special for you. As you can see, I am broadcasting today from the cockpit of my very own Millennium Falcon. You might remember a few months ago, I mentioned I was at the Intergalactic Fortnite Championship. I didn't win. I came third. That's why I only got the Millennium Falcon. The second place guy won a Death Star, and the guy who won got one of them really cool electrical scooters. I wish I'd come first. I really want one of those scooters. But hey, it's a Millennium Falcon. It's not bad, and it's very appropriate because today we're going to take a journey sort of into space. So let me get sharing here. Yeah, the old Loserbum homepage. Are you doing very well? I see we have more views and more likes, so thanks for that. And what we're going to look at today is a video. Remember last time I was talking about the power of, right? Powers of 10. So the video is actually called Powers of 10. That's what we're going to be looking at today. So remember, powers of 10 is like the number of zeros. So we'll get into that into just a second. And this film, as you can see, is from 1977, so it's over 40 years old. So we start on a picnic. This is actually in Chicago. Can I full screen this? That's as full screen as it gets. There we go. We start on a picnic in Chicago. One lazy afternoon in early October, and we start with 1 meter wide. So like that guy's maybe 1.80 m, so that's 1 meter. And every 10 seconds, we're going to go up 1 power, right? So 10 to the power of 1, so that's a 10-meter square. In 10 seconds, we're going to be 10 to the power of 2, so 100 meters square. Every 10 seconds, we're going 10 times further out. That's the power, remember from last video. So here, you know, we already can't see the people anymore. We can see a harbor. Now we're at 10 to the power of 3. We can see a whole harbor here. I think that's an airport with the landing strip. This is the city of Chicago. So we're still at 1 kilometer. Now this square is 10 kilometers, 10 to the power of 4 meters. Got a bit of the lake, a bit of the city. It's a very large city. And 10 seconds again, we're going to be at 100,000 meters. So 100 kilometers. This square is 100 kilometers. It would take you an hour to get from there to there. Here we start seeing the Great Lakes, 10 to the 6, 1 million meters. So 1,000 kilometers from here to here. Take you 10 hours to drive that. Now you can start seeing the American continent, you can start seeing the whole Earth. So now we're at 10 million meters, 10,000 kilometers. That's about the Earth. And every 10 seconds, we're going out and out in our Millennium Falcon. Pull that up a bit larger there. Oh, no, that's not nice. All right, 100 million meters. That's where we are. Earth is starting to get very small. That line you saw down there, hang on, let me pause there. That line you saw down there was the actual speed of light happening. I will just play that again. So you'll see a line going from there to there, and that's how fast light actually moves in real time. So in 1 second, it's doing about 300,000 kilometers. That's how fast the speed of light. What you see there is the moon, which is about 300,000 miles away. Now we start seeing the orbit of some planets. Right, the planets which are on the inside of the solar system, like Mercury and Venus, you start seeing them. We're now at 10 to the power of, let me make myself smaller here. Yep, 10 to the power of 10. So 100,000 million meters. Now we start seeing the orbits of the bigger planets. We got the sun over here. We've got the bigger planets out there, like that one's Mars. This is Jupiter, Saturn, and we're at 10 to the 12, so 1 million meters. Right, so, and now 10 more seconds. That one crooked one out there is the orbit of Pluto. Remember, this was done in 1977, Pluto was still a planet. We're at 10 to the 13, 10 million meters, and the entire solar system is just these few pixels in the middle. And we're still going, 100 million meters, or you could say, once we reach 10 to the 15, now it's a million kilometers. In the background, we can see the stars. They're so far away, they're not really moving yet, but they will soon. So still, you know, we're now at 1 light year, which is about 10 to the power of 16 meters. And we're still going out. And you notice there's no other stars. It takes a really long time to get to the nearest stars that we have. So 10 light years. We're now 10 light years out. We're starting to see the first stars out here. Let's see, what were they called? Yeah, anyway, 10 to the 18. So now, because we're so far away, the stars in the background are actually starting to move relative to us, or it appears. And what you're seeing here at 10 to the 19 meters is actually the Milky Way. Because of the way we flew out the Milky Way is a disk, it's flat, and we're flying out vertically like that. So we can actually see the Milky Way side on. From where we normally stand, we look like in this direction, so it's just a stripe in the sky. 10 to the 21 meters, we can see our entire galaxy. There's like 100 billion stars in here. It's 100,000 light years from side to side. Here's a couple of tiny little other galaxies which are next to ours. We used to think that ours was the only galaxy. We were wrong. At 10 to the 22 meters, we start seeing other galaxies. This is called the local cluster. So there's a bunch of them. It's only 10 million light years. This other cluster of galaxies is called the Virgo cluster. When people discovered that, blew their minds. You mean like we already got billions and billions and billions of galaxies, and there's others of them? And the video stops here, and then we're going to start diving back in, and we're going to dive in 5 times as fast. So instead of a factor of 10 every 10 seconds, every 2 seconds, we're going to be diving. Nowadays, if we were to do this video, we'd be going even further out, because thanks to the Hubble telescope, we know how big the universe is. And we're diving in, and here's a little star, and that's the Milky Way, and we're in one of the spiral arms, and we're zooming in, and here are some stars near us. That's a star which is 10 or 100 light years away. 10 light years away, we're diving in at full speed, and we're going down. Can we see? Yes, we can see the solar system, and that's the sun, that little blue dot, and that tiny little thing. Now we can finally, no, still not, at 10 to the power of 9 meters. Now we can start seeing Earth. Now imagine all that zooming out. Maybe we're not that important after all. Here we have the Great Lakes, America, and we're falling, we're falling. Are we going to splat into Chicago? No, we're going to slow down just a little bit now, and we're back on our pictics. 10 meters, 1 meter. That square is 1 meter. Now we're going to slow down, and we're going to go in at the same speed. So if you go in, it means you go minus. If you go 10 to the minus 1 meter, that's 10 centimeters. 10 to the minus 2 meters is 1 centimeter. Then we go down to millimeters. Then we go down to nanometers, picometers. So, yep, that square is 1 millimeter. That's the pores of your skin. These are actually dead skin cells on the outside, and we're diving into that pore. And that thing here, sorry, this is 1 millimeter, I guess. Yeah, this is 1 meter. We're diving in and diving deeper into the cracks of your skin. Your skin looks smooth, but here it looks like a mountain range or something. And here we now have some blood cells. There's the blood cells in, blood vessels. And at 10 micrometers, we are now seeing a blood cell. This is a white blood cell, which are actually quite large. Here we see the outside of the cell with the little holes in. And now we're going to 1 millionth of a meter. It's called a micron, 1 micrometer. And we're actually going inside the cell itself. That zigzaggy stuff you see here is the DNA, the part that makes the cell know that it's a skin cell. As we go there, this is everything you are is coded in here. There's little atoms in here which kind of hold the computer program which builds, or the biological program which builds you. And now we're down at molecular level. So this is a simple little molecule with a carbon atom in the middle and 3 hydrogen. It's starting to flicker because we're so close, and now we are inside the atom. What you're seeing here is the cloud of electrons, right? So an atom has some electrons around it. We're at 10 to the minus 10 meters, also called an angstrom, and all we can see is these clouds of electrons which pop in and out of existence. And see, again, it's a bit like the solar system, where there was like lots of stuff and then just blackness, blackness, blackness. And so we had the electrons, and we've gone in by 3 powers of 10, and here we see the nucleus, the core of the atom. This is inside of an atom. This is a carbon atom, which means it's got 6 protons and 6 neutrons for an atomic mass of 12. So one of these is a proton, one of these is a neutron, and this is as far as it goes in 1977, because back then that's where our knowledge as human beings stopped. Now we know that below the protons and below the neutrons, we have things like quarks, and we have the Higgs boson, which was just discovered a few years ago. And the reason why it's all so fluffy now is because, well, light can't even show what's happening there. Yeah, so that's pretty exciting. We just went from 10 to the minus 15 right at the end, right? So that's a 0, comma 000, and then you have 15 zeros and a 1. So it's like, let me try and work that out. Billion. It's 1,000 billion billionths of a meter is where we're down. It's so unbelievably small. So 10 to the minus 15, all the way up to 1 millimeter, all the way up to 1 meter. And then when we zoomed out into space, we were at 10 to the 24, 25, I think is where we stopped. So we went through 40, that's 40 powers of 10, which is amazing. So 40 zeros behind from the smallest to the biggest, and from there you have pretty much the whole of existence, right? You have the entire universe all the way down to the little subatomic particles, what happens below the atom. Makes you feel kind of insignificant. And yep, and what we see here, there's a lot of blackness, a lot of nothing happening, and then all of a sudden, bam, you have the galaxy. Just like when you zoom in all the way, you have not much. These are not stars, these are electrons, but they look like stars. And then you go and there's nothing, and bam, instead of a galaxy or the sun in the middle of our solar system, you have the nucleus. That's what the universe is like. Lots of blackness, lots of nothing, and then all of a sudden, mad activity, mad proton stuff happening, or mad galaxy stuff happening, or maybe just the planet Earth. Yeah, so welcome to that little space trip here. Maybe one day we'll do something else about space. There's new versions, as I've seen in YouTube, which are being made more like in the last 10, 20 years, which have nicer graphics and more information, because we've learned more about the universe, not the university. And what's kind of cool about this one, which is, takes it back. Why is Loserbum talking about this stuff? Well, because I had the Millennium Falcon, I want to take you into space, but it's also because this is retro. As we said, 1977, this is retro technology. To make this film, they had to make all these pictures by hand. They either took them from telescopes, or they made really them by hand and made this movie really really with a lot of work. It's 10-minute long. That's tens of thousands of pictures they had to make. This might still have been a photograph, but here somebody would have had to draw this and zoom in and photograph it. Nowadays, we've got computer-aided graphics. We can make this much better. So in a future episode, we'll climb back into the Falcon and we'll see what this kind of stuff looks like today with the modern technology. That was the trip into the universe and into the microverse powered by Loserbum. Yeah, that's about. Oh no, hang on. Wait. There's one thing I want to say. Well, first I want to say, if you like the content, remember to like, share, and subscribe, and tell your friends to like, share, and subscribe. But there's something actually brand spanking new, which I want to share with you. If you go to your browser and type in loserbum.com, I hope you know how to spell Loserbum, you have our fantastic website. It's unbelievable. I mean, look at the quality of this website. But it means you can buy some merch. We have genuine Loserbum merch. I don't make any money out of this. I just want the universe to have really cool tea mugs, t-shirts, shopping bags, and caps. So why don't you hook up your favorite merchandise there? And this also has access to the Loserbum homepage. Also will take you to the Twitter feed. Loserbum's got a Twitter feed, which I've actually got to update in a moment to say that there's going to be a new video there. So remember to like, share, and subscribe. I love you all. You are the best. I'm Loserbum, you're the internet, and I'm out of here.